Hello, folks. I'm having a little bit of trouble with transmission, so I don't really know what's going on. If there are problems, let me know. All I see is a still image, so I don't really know what's going on. Let me know if there are some kind of problems with the images. Okay, I have no idea why I'm not getting images, moving images. All I see is a snapshot. Okay. Loud and clear. Can you see me moving? That's the issue because I can't see myself moving on the screen. So I have no idea what's going on. Okay, thank you. Anyways, welcome to Rational Science, and we have a busy day today, so I'm going to get right into it. We're going to be dealing with space and whether it's infinite or finite. Okay, the big question there. And I'm going to be answering some questions that people or some issues that people raised. But let's get on with our extinction segment and related topics so that we can get quickly to the subject matter today. Okay, so here we have. Lately, we've had the ETs. I've talked about that in the last couple of weeks, and it says there that one article that came out says 34% believe UFOs are probably alien ships or alien life forms, up from 20% in 1996. So it's quite a bit, quite a popular subject. Another 34% said they didn't know, and 32% said that there's probably some scientific explanation for it, okay, or some rational explanation. And it says, we have a lot of interesting videos and pictures, but not a whole lot else. And that's true. There's no real evidence, no hard evidence, okay? No other country seems to be citing nearly as many UFOs as the U.S. Looks like all the UFOs are going to the United States primarily, right? And much of it is probably product of movies, okay? So there's a lot of hype, propaganda, movies, etc., and that's what people then repeat, and that's what they talk about. Okay. Okay. Here's another thing that's popular in the news related to UFOs, and it's the fact that they shot down a couple of things out there in the space, or they saw some things, they don't know what they are, and they call them UFOs or UAPs, right? One shot down was one of the things shot down was that Chinese balloon, but then there's some other stuff that has been unaccounted for, and this also fuels the conspiracy theories out there that maybe the government is hiding something that they know more than what they tell the public. And the question is, why would they do that? I mean, in the case of UFOs, I never understood that argument quite well. I think people would probably like to know, and I don't know if they're gonna go into panic mode. Just bring the ETs out, the little green men out, and let them talk to us and so on. I think that's the way it should be. This fellow, who we've talked about him a couple of last times, named Davy Grush, and he's or was, I don't know if he still is, a government man, and he says, hey, I'm going to blow the whistle because it turns out they do have some extraterrestrial parts out there, or maybe even living beings, right, that the U.S. government has collected, and they just don't want to tell the public about it. Okay, and what's incredible to me is that this ended up in Congress, that they actually had a meeting on this, a session on this nonsense. That's what's incredible, and that does make people suspect, not necessarily me, okay, but it makes people suspect that maybe there's a purpose behind it. Maybe the government's trying to do something, fool people and so on. All these conspiracy theories come up as a result of that. Because of people like Grush. He goes up there and says, I saw. what he should do really is name names. That's what he should have done in Congress. He should have said, look, Joey and Tommy and Susie, they saw, or I saw how they handled, some extraterrestrial beings, so that they would bring those people in. Say, okay, yeah, yeah, Mexican guest. Bring them in and let's find out. Let's get to the bottom of it. Who has handled all these aliens? And that's what Grush should have said instead of saying, "Oh, the government. The government is too big." He should really go in there and say, "Look, it's Joey and Susie. Those people that I know. I saw them handle, parts of a flying saucer or parts of a living entity that came from abroad, from outside the Earth." That's what they should do. And so, yeah, unless he names names, he just says the government. That sounds like he's going to go on a speaking tour or write a book. That's what it sounds like to me. It doesn't sound like anything serious. And here we have another fellow, and he's a CIA or ex-CIA, and this fellow, John Ramirez, he says, if you're paying casual attention to the headlines, it might feel as though there's been a shift in the extraterrestrial tides. These days, the existence of visiting extraterrestrial doesn't sound so unrealistic. According to former CIA agent John Ramirez, there's a reason for that. And what is that? It says, after leaving the intelligence community, Ramirez has enjoyed his second career as a UFO aficionado. And sounds like, again, this fellow who wants to go on a talking tour, maybe write a book, right? Making the rounds of the podcast circuit to tell the world what he allegedly knows. In February 2023, he gave an interview, right, during which he warned of an oncoming alien revelation in 2027. So remember, oh, okay. Thank you for confirming that. He's saying in 2027, the news is going to break that they do have all these aliens and they're going to present them on TV, I guess, who knows? And anyway, he says, according to Ramirez, the recent disclosures, whistleblowers, and underwater discoveries are all part of an intentional narrative to prepare the populations for the day aliens show up. A day, he says, is only a few years away. Okay, so he's saying they haven't showed up, I guess. They're going to show up in 2027. We're kind of preparing the U.S. population, at least, and by extension the world population, to that reality. Okay, so these people are just charlatans, they haven't produced anything. They're just blabbing, and I think they're going to go on a circuit, talk circuit, or they're going to publish a book or one of those, and they just want to be popular. They just want to get on the internet, people shake hands with them, interview them, all that kind of stuff. It's all nonsense, okay? There is no possibility, first, of extraterrestrial life visiting the Earth or us visiting any extraterrestrial life. As I said in the past, any intelligence of our level, of human level intelligence, there's no higher intelligence level than humans anywhere in the universe. Mother Nature has run out of, blessings to give. This is it. If you don't have enough intelligence, well, you got to take that up with your mother, maybe sue her. But, we're the highest level of intelligence that the universe can bequeath. Okay. And once, human level intelligence develops in any planet, it's only got a small window, maybe 200 years, and they go extinct. That's where we're headed. We're going to extinction, headed to extinction very soon. I don't know if 10, 20 years, maybe 30 years, I don't know. I can't give you a date. All I can say is we're very close to extinction, and in that short amount of time, we have no chance of visiting another planet or receiving messages or sending messages. Well, we can send the messages. No one will ever receive them, and the same happens to those civilizations. They can send something out, but it'll never reach here, or by the time it reaches here, we'll never catch it. It would have to come in our direction, et cetera, et cetera. It's too far away. Everything is so distant in the universe. There's absolutely no way we can communicate with another civilization or them with us. And more important, the time window is very short. You only have like 200 years in which you develop technology where you can send things outside the earth, when you can send electromagnetic waves, of any decency, any decent waves out there, and then we go extinct. And same happens to any other civilization like us that develop anywhere in the universe. So there's no chance of anyone coming down here. We don't have to look at the skies and say, well, maybe they come here. I mean, we got to be, pending, waiting to see if or looking at the sky, observing, because they might show up any moment. It's never going to happen. Okay, so all these people are just charlatans, and they have no sense whatsoever. Now, maybe they're just trying to make money, and that's fine. I can understand that. Maybe Hollywood, makes a movie on their stuff. That's great, no problem. But to actually believe that the ETs are here, or that anything extraterrestrial, meaning from a intelligent civilization, ever came here or ever will come here, that's nonsense, absolute nonsense. Never will happen. Okay, changing the subject a little bit, here we have climate change, and it's another issue that they've been peddling for some years, and they have people all riled up on it. It says in the past 8 years, sea ice in Antarctica has reached a new record low 4 times. The first 3 times, ice levels that have dropped in the summer have rebounded in the winter. But this year, during what is currently winter in Antarctica, scientists have confirmed that the ice is not reforming, leaving long stretches of the Antarctic coastline bare. What's happening? According to physical oceanographer so-and-so, this is the first time an event like this has been observed, and it's extremely unlikely to have happened on its own. We'd expect to see a winter like this about once every 7.5 million years. Okay, so what is this individual, and what is the article saying? Saying that the Arctics are melting, not only the Antarctic, but the North Pole as well. You see the picture of the polar bear sitting on a shrinking ice. So we have a little bit of what is known as global warming. We've had climate change all the way since the Cambrian, and even before that. There's always been climate change. Now, are we creating some of that climate change today? Humans, 8 billion people throwing garbage up in the air and heating up the atmosphere? Very likely. Very likely. I have no problem with that theory that we could be creating or helping to create a warmer environment around us. What I'm saying, it's got nothing to do with anything. Okay? We're going to have extinction very soon for a totally different reason, and climate change is going to be at least 200, 300 years away. In fact, here we have another article along the same lines, from the same group, by the way. It says the following: scientists are sounding the alarm about a dangerous problem that will soon affect 2 billion people. Here's what to know. Recent findings published in Nature show that without policy changes, the world will heat up enough by the end of the century that more than 2 billion people will live in life-threatening hot climates, etc. Right? The new study found that with the current laws, population growth, and environmental conditions, the world will likely reach about 4.8 degrees Fahrenheit above the pre-industrial benchmark. Okay, so the world is heating up. That's what they're saying. Okay, and so why are they scaring you? Well, because they're saying, this heating up is going to create problems in the future. What? By the end of the century. I don't think we're going to make it to the end of the century, personally. I doubt very much that we'll ever make it to the end of the century. More than likely, we're going to die somewhere between today and the end of the century. I don't know, midway or whatever. But the point here is that climate change will have no bearing on our lives. Okay, maybe, well, I can't say no bearing. I mean, maybe there's going to be some flood somewhere because ice melts, etc. Yeah, but it's not going to kill us, and we don't have to worry about the future because there ain't no future. So to raise the issue of climate change the way these people are doing it, is just a lot of talk. They're just pretty much like the ETs and the flat earthers and all these people, right? Okay, more important stuff, and this you have to pay attention to. Yeah, this part I think is very important, and that's this. China's stalling economy puts the world on notice. Now, this is, I think, important news. The engine, China, is sputtering, posing alarming risks for Chinese households and economies around the planet. China has devolved into the ultimate wild card in a moment of extraordinary uncertainty for the world's economy. Absolutely. Too big to fail, you know. The risks have been amplified in recent weeks by a slew of developments. China's exports have declined, prices have fallen on a range of goods, right? Distress in China's housing market and a weakening Chinese economy signal a shrinking of demand for major goods. And we're not only talking about the people in China, we're talking about the world, which is selling and buying, with China. China being, approximately a quarter of the world population, right? The slow quarter, maybe a little, maybe 1/5 or thereabouts. Anyways, the slowdown in China is definitely going to weigh on the global economic outlook. Absolutely. If China is having problems, it's going to affect everybody because China is now the number one commodity consumer in the world. The impact is going to be pretty big. That's what that article said, and I have to agree with it. If China, China cannot grow forever. China was growing. I think in the days of Deng Xiaoping, it was growing around 25%. Why? Because China was so backward that with technology they were able to make great advances, and suddenly the economy of China expanded exponentially, and so they were growing at 25%, and some countries were a little worried about that. Today we have the result of that. They went from 25% to 15% to 10%. Today I think they're only growing around 5%. And that's normal for any economy. It eventually reaches this plateau. It approaches the asymptote. And at that point it levels off and it grows only at 2%, 1%. And that's going to have an effect like, Europe and the United States are growing very slowly now. Why? Because they're completely developed. And the only reason that Europe and the United States continue to grow a little bit is because of immigration. That's why, they allow immigration from African countries, from Arab world, from South America, people from those countries or those regions. Why? In China, also the Orient. Why? Because they bring in consumers, they bring in workers at the lower level, and that pushes, for example, here in Germany, it pushes the Germans a little higher. So it's good for the country. But that's the only reason they're growing, because they're not producing children here. And so they have to, increase the population, which is where growth really is, demand, etc., right? They have to increase it through immigration. But countries like China, they don't have too much immigration as far as I'm concerned, and Russia and Japan even less. That's why those countries are stalling, because they have no population growth. They're in negative population growth, and this is the plan for the whole planet. Okay, the only reason advanced nations are still growing, those that are still growing are growing, is because of immigration. Okay, that's what's helping. That's why they opened the doors to select people. They take the best people out of every country and they try to grow, higher and higher. That's the plan. But if it weren't for that, the economic systems of Europe and the United States, especially, Canada, etc., they would stall. And that's where China's headed. So the whole planet is really approaching asymptotically maximum economic growth. And what happens after that? That's the big question for you. Okay, and just in case China's having problems, well, the United States is adding problems to China, because it says lawmakers pledge to double down on Biden's new China investment ban. Okay, and says that the Capitol Hill lawmakers from both parties immediately pledged to go further in the coming months after President Biden announced his effort to prohibit Americans from investing in some Chinese companies. And what they're looking at is tech related companies. They don't want anyone investing in those companies in China. And they also want to limit the amount of technology that is sent to those companies, because they're worried that they're going to use them for military purposes, and also to make China more advanced technologically, etc. And so that's on top of the fact that China is also already leveling off. Its economic system is leveling off. So once we killed China, which is the engine of the world right now, the economic engine, where a lot of people, a lot of countries are dealing with China. Once that slows down, everybody slows down. Okay, and maybe India will pass a little bit, Bangladesh, Indonesia, some of these countries that are quite backward still. They might make some advances, and that might take off a little bit of the slack off China. But the point here is that eventually the whole planet will reach a point where there is no more growth or very little growth. And that's, I think, where we reach the end of the line for all of humanity. Because at that point, we're on the last stretch, so to speak. Okay, we have very little to go after that. That's my 5 cents worth. Okay. Okay, let's move on to the subject matter of today, and that's going to be space. Is space infinite or finite? I mean, how big is space? Okay, that's what we're going to deal with. And in order to get there, I'm going to start with some questions or some issues that a fellow raised, and I answered him last week, but he still didn't get it. So he came back for more, I guess, more punishment. Okay, and so here goes. This is what he had to say. Says, so water is not a thing because it has no shape. You're wrong again. Okay, is water a thing? Well, let's find out. Here's a blob, okay? And you can see the astronaut has just thrown that blob of water or whatever that liquid is, whatever fluid you've got there. And the question, you can think of it as water, right? A drop of water. And the question is, does that drop of water have shape? And hopefully your answer is yes, because that's the rational answer to what you're seeing in front of you. That blob has shape. Now you might say, well, what is the shape of the blob? And the issue is that that's not the question. The question is not what is the shape of the blob. The question is, does the blob have shape? In other words, it's a yes or no type of question. Water does have shape. And you can throw it in, out there in space, a bucket of water. Take an astronaut and he throws a bucket of water, and that water just splashes out there. And you take a snapshot at a given moment, anytime, no problem. You take a snapshot. When you look at the snapshot, you got a picture there. It's a still image. Does something appear on your photograph? And if it does, well, that's shape. It means water does have shape. Okay? And so you can't say that water does not have shape. So water is an object because it has shape. And you had people like Ayn Rand who thought that liquids or fluids in general were not entities, as she called them, objects, things, because I guess in the back of her mind, she couldn't figure out, well, that doesn't have shape, so it's probably not a thing. Anything that's made out of atoms had better have shape, because every atom has shape. You have all these things with shapes, and you build this other thing, a table, a chair, a rock, whatever, and that has shape. Anything that has shape is an object, period. We're done. So yeah, water does have shape. Okay, so this fellow thinks that it doesn't have shape because, it's too fluid. He can't tell what shape it is. It's not the question of what the shape is. It's the question, does it have shape? It's a yes or no type of question. Okay, he continues, says, the ether is the field. It's a real substance, just like water is. Who cares about the word field? It's only a word. We know there is something there for electromagnetism and gravity. And so he continues on his rant. And the issue is, is a field a thing? And he thinks it is because this is how he was educated at the monastery, obviously. These people think that energy, field, wave, ether, plasma, they think all these words represent objects. And they don't. They represent concepts. And it takes a mathematician or one of these folks 100 years to understand that. They don't understand that, and when you get into those things, they say, oh, you're doing semantics, you're doing word salad. And that's exactly what he accuses me of. He says, your ropes are invisible too. Yeah, they're invisible. So what? Like I said, it has nothing to do with visibility or touchability. It's got nothing to do with intangibility or, whether we can touch it or see it. And pure assumption, hopefully. We begin with assumptions in science. We said, let us assume, that God exists. And we don't care if he's invisible or not. We just make an assumption that he exists, And so he says, so no better than the ether. No, it is better than the ether because the ether is a concept. That's the difference. The ropes are, take a rope. And here, let me show you one because apparently he's never seen a rope. He's never been to a hardware store. Here's a rope. Does it have shape? Does this item I have in my hand have shape? Hopefully the answer is yes. Okay, it has shape, therefore it's a rope. And each one of the threads, we'll call the red and the blue ones, each one a thread. Each thread also has shape. It's 3D, etc., etc. So threads, ropes, cables, wires, coaxials, all have shape. All of them. So all are things. Ether is not a thing because ether doesn't have shape. What does ether look like? Well, let me show you what ether looks like. First, let me show you this. This is what the ether is, okay? There's a bunch of particles. Move it around, okay? So what is the ether? Is it the black stuff? Is it the white stuff? If it's the white stuff, what's the black stuff? Or is the white stuff the same thing as the black stuff? And what these people usually do is say, well, Bill, that's not the ether. And that's the answer I always get from etherists. They always tell you what ether ain't. They never tell you what ether is. That's what I want to know, okay? So if you don't like my ether, you tell me what the ether is. And hopefully you don't define it. Hopefully you point to it, okay? If you define, it's a concept. If you point, it's an object. So you have to tell me if ether is an object or a concept. Can you point to the ether and say that's ether? Like you would point to a rock or to a tree or to a house and say that's a house. That way the ET understands your language. The ET doesn't know your language. You come here and you got to teach him the nouns. And you got to say, look, that's a house, that's a tree, that's a rock. Now he learns your language. He knows what you're referring to every time you say rock. Likewise, we say rope. We point, say rope. No problem. Thread. You point thread. You can point to a needle with a thread coming out of it and say that's a thread. That's no problem. Everybody understands that. What do we point to when we say ether? That's the question. If you can't point and say ether, you can't show me a thing in front of you, then then ether is not a thing. Okay, and so this is what they define it as. Okay, couple fellows there says we may say that according this is Einstein, to the general theory of relativity, space is endowed with physical qualities. In this sense, therefore, there exists an ether. According to the general theory of relativity, right, space without ether is unthinkable. So space-time was the same thing as ether. What is space-time? 4 number lines, which they call coordinates or dimensions or something like that. 4 number lines, that's what space-time is. And they say that's equal to the ether. So is that what the ether is? If I ask this fellow, are you going to define it as 4 number lines? Is that what the ether is? And then we have another fellow, he's a Nobel Prize winner, right? The modern concept of the vacuum of space, confirmed every day by experiment, is a relativistic ether. But we do not call it this because it is taboo. Yeah, that's the issue. The issue is they treat it as an ether. All they've done throughout the years is change the name. They called it space-time. They call it first they called it the ether, then they call it space-time. Today they call it the false vacuum or whatever. And they're always talking about the same thing. And they're talking about particles. That's what the ether was always. Many particles filling space. It was the air. That's what ether means. It's the air. Ether is another word for air. But this was the air of the gods. And so what was air? Well, they imagined it as a bunch of particles. And so what is the ether? A bunch of particles. They were just godly particles. That's the only difference between air and the ether. Okay, and so this special air was kind of outside and it was handled by the gods. They could see it, but we couldn't. And so they used the word ether to refer to that. And everybody after that also treated it as a bunch of particles. Newton treated it as a bunch of particles. Huygens treated it as a bunch of particles. They all treated it as a bunch of vibrating particles. That's what they imagined. And so when these people say, well, that's not the ether, then what is the ether? According to you, you got to tell us. You're giving the presentation. You're giving the dissertation. You got to tell the crowd what you mean by ether. You can't just say, oh, the ether. And this fellow says, oh, the ether is the field is the ether. Great. Here, when you look up the ether, and I challenge you to do this, okay? Go to Google and do a Google search on images, and you'll get something similar to what I got here. That's the ether, okay? All those are different versions of the ether. So the question is, what is the ether? Nobody can tell you. Nobody can show you a picture of the ether. Okay, they say, well, let me explain it to you. Let me define it. And so we have a problem because if ether is going to be used as a physical object, you're going to say the ether vibrates or something along those lines, or it moves the wind or whatever, or it's gravity or whatever. Then you have to point and give me a picture. You get a still image before you move anything. Show me a picture of the ether. And if you can't do that, ether is not an object. And you can say, well, it's infinite. No, there's no infinite object. All objects are finite. That which has shape. See how simple it was? You should be able to give me a picture of the ether. If you can't give me a picture of the ether, then ether is a concept. And if it's a concept, you have to define it. You have to tell the crowd what you mean by the word ether. Very simple. Okay? And so these people don't do that. Okay, so this fellow continues. He says, you're deliberately ignoring real mechanisms because you're indulging in what? Stupid word salad. You're being ridiculous. Okay, thank you. Faraday knew there was something there. Real physical, not just concept. Yeah, if it's something, something is something that you have to illustrate. You have to show an image of. So Faraday never defined the word something, but if he thought there was something there, he left it in the open because he said, I don't know what's in there, but there's something in there. He did say that. So what? I mean, we need to find out what that something is. And it's up to the person giving the presentation to tell the crowd what that something looks like if he's going to talk about something. Okay, and he said it's not a concept. Well, you got to define what something is and what a concept is. Unless you tell us what your definition of something and concept are, we have no idea what you mean when you say concept, when you say something. Just that simple. It says, call it a field, call it the ether, or 0 point energy, or the Getty. I don't care. You're completely irrational. You cannot be reasoned with. I have nothing more to say to you. Yeah, and that's what these people do. They run away. They escape because they can't tell you what the ether is. They get frustrated and they say it's like a field. Well, what's a field? Here's the field. Let me show you the field now. Okay, ether's like a field. Okay, here's the field. Okay, there's your field. That's what people have in mind. Some kind of three-dimensional spider web that is shaking, and they say, oh, that's the field. Okay, so what is that? What are we staring at? And again, these people might say, well, that's not the field, Bill. Okay, so what is the field? If you look it up, you find a definition. You don't find a picture. What you find is a definition. The definition is values. Values at each point in space. So they're talking about numbers. It's a mathematical concept. That's what field is. So you can't say that a concept such as love does something. Love moves mountains, not in physics. Okay, you can't say love moves mountains in physics. A heart might be able to move a mountain because a heart is a thing, but not love. And these people confuse field with an object. And they think they're talking about a thing. Okay, and they say, oh, this thing is vibrating, this thing called field. And so he's saying something in there is moving. Yeah, that something is what you have to identify. And it's not the field. The field is infinite, remember. A magnetic field and an electric field, they extend forever. That's what the official version is. That's why you have to clarify. If you don't like that, you have to clarify it. But right now, the official version is that a field extends forever. There's no object that extends forever, therefore a field is not an object. In fact, a field is just a bunch of numbers with decreasing values, decreasing strengths away from ground zero. That's all it is. Just numbers. It's a mathematical concept. If you say there's something physical in there, you got to identify that physical thing, give it a name. Can't be the field because the field is the whole shebang, right? So you got to say what it is that is vibrating inside that region we call field. Okay, so that's the way it works in science. Okay, so here we have field. Look it up, and it says a physical quantity that has a value for each point in space and time. So it's a bunch of numbers that are vibrating. That's what they do. They vibrate numbers in mathematical physics. And this is what these people think are physical objects. So they treat the word field as a physical object. And they get upset when you point that out to them. You say, oh, you're doing word salad. You're doing semantics, you know. Okay, so here we have, but he said the ether is the field is the ether. But here you can see that they're very different. The ether is the one on the left, field is the one on the right. They don't look the same. And again, the guy says, hey, you're making fun of me. Yeah, but see, it's up to them to tell the crowd what the field is, okay? And what the ether is. You can't continue, using these words like they use them now, which is, as concepts that they turned them into objects. They reified these concepts. They concretized them. They made them concrete. And they don't realize that. They don't realize that they're dealing with a language that was given to them by the mathematicians, whom they criticize, by the way. The electric universes, they use these concepts as well as physical objects. Where did they get the language? Where did they get the word plasma? They got it from the mainstream they criticize. So if you don't like the mathematical physics because you say, oh, that's irrational, then you can't use their language. If you're going to use their language, you're going to run into trouble because their whole language is screwed up for the last 100 years. That's why they don't have any rational explanations for anything, for any phenomena. Okay, so what does this fellow do? He says, but you're asking me to define words scientifically, Bill. That's word salad, just semantics. Yeah, when you ask them to define words, they don't like it. They say, hey, you're doing something that is not scientific. I came here to do physics, they say, not to learn English or to do grammar or semantics or ontology or any of that. So this is the problem, okay? Okay, give me a second here. Okay, so here we have field, okay? Another fellow, he says, what if the field was a range of potential quantum positions of a thread? You can't mix the rope model, the thread, right, with anything in quantum. Quantum talks about particles. In other words, discrete entities which are not particles either, but they use the word particle to mislead you. They say, oh, particles. No, they're not talking about particles. But what they're referring to, because that's what they use in mathematics, they're referring to values, discrete values. So they say there's a value here, there's another value here, another value here, and the whole shebang we call a field or whatever, okay, or energy or mass, right? But quantum mechanics deals with discrete things. Why? Because they can put those values in an equation. You can't put a rope in an equation. You can't put a thread in an equation. Okay. In fact, you can't put a particle in any equation, a corpuscle, right, or a dot. No, you have to put a number, and that's what the word particle means in all of mathematical physics. When they use the word particle, they're referring to values, to amounts followed by units. That's what a particle is to a mathematician. They don't know anything about objects, about things. That's why they never defined the word object anywhere in physics. Just get any. Take my word for it. I'll give you a beer if you can find any textbook on planet Earth of physics, right? Secondary school, high school, college, that begins by defining the word object, what a thing is. You won't find it. No one in the last 2,000 years discovered, in physics, right? Discovered, researchers, theorists, discovered that the first word you need to define in physics is the word object. You can't do physics without objects. If there were no objects in the universe, what's happening? What are you staring at? What are you experimenting with? What are you seeing? What's happening? Nothing. You need objects. And they never realize that. Why? Because all they do is math. They do descriptions of movement. And that's what an equation is. Okay, so here we have a definition of the word space, because that's the subject matter of today. And again, remember, the field is space, space is the field. They're synonyms according to the religion of math. And it says a three-dimensional. So space is three-dimensional. 3D, I thought space was zero-dimensional, but they say it's three-dimensional. Continuum. Aha, continuum, what a word. Containing positions and directions. Okay, that's out of the Wikipedia. And it says modern mathematicians, I don't think it said mathematicians, but I felt a little literary liberty to put it in there, okay? Usually consider it with time to be part of a boundless, four-dimensional continuum known as space-time. So obviously we have to get down to the nitty-gritty of what this word continuum is. So what is a continuum? It says gradual quantitative, okay? Gradual quantitative transitions without abrupt changes or discontinuities. So they're talking about a number line. Okay, that's what they're talking about. And they're saying transition, I mean, even quantities, they're all discrete. No matter, you get the number line, no matter what part of it is always a discrete number. But they say quantitative transitions without abrupt changes or discontinuities. So that's what space is, just quantitative transitions. Okay, but they're three-dimensional. So they're like a cube. Okay, it's three-dimensional. That's what space is. Anyways, then he continues, says, the concept of space. The concept? I thought you said it's three-dimensional. I thought you said it's an object, that's a thing. And now you're saying the concept of space is considered to be of fundamental importance to understanding of the physical universe. I mean, it's important to understand the physical universe, and they don't know what it is. And they define it as three-dimensional, and then they say it's a concept, a three-dimensional concept. I mean, is love three-dimensional, four-dimensional, two-dimensional? What is love? What is intelligence? Is it two-dimensional? How about information? Is that five-dimensional? So this is the problem. They have all these contradictions, and they just pass through them. You know, they just gloss over them. Anyways, you look up the word concept. What is it? An abstract idea. What's abstract? A concept. So abstract is a concept, and concept is an abstract. Great, we learned a lot. And what's an idea? The result of thought. Whatever that is. Okay. So yeah, we don't learn much from the establishment, the scientific establishment. They have no definitions, no scientific definitions. There's no definition of the word life. Therefore, there's no biologist on planet Earth, because biology is the study of life. Nobody knows what life is. Nobody can define it. But here we have a discipline that deals with it. Okay, and so on and so forth. We have that all around. There are no definitions you can sink your teeth into out there in the scientific world, in the world of research. People who call themselves scientists. Okay, and especially in mathematical physics, there's no valid definitions. They use all these definitions, like fields, energy, and so on. Their definition, they treat them like physical objects. And here they do the same thing with space. Space is what? Three-dimensional, and they say it's a concept. So it's a three-dimensional concept. You figure it out. Okay? And you say, well, is space something out there? And people say, yeah, see, because I can point with my finger to space. Well, what are you pointing to? Well, you see, there's the moon, and whatever's around the moon, that dark stuff, that black stuff, that's space. And I can point to it. See, I'm pointing to that black space. So here you have the moon, okay? Okay, you can point to it and say, okay, here's the moon. And the black stuff, we call that space. Okay, seems straightforward, but we don't know what it looks like, because I had to chop it off with that rectangle, but obviously space continues. What is the shape of space? I mean, does it continue? And what happened was that these people say, I can see space, because see, I can see the black stuff. Well, that's kind of strange, because you would think that space is nothing, vacuum, emptiness, and they say they can see this stuff. I mean, you had what in the 1930s they created a character. His name was Superman. Okay, for those of you who are familiar with Superman, and he had a very strange power, and that was that unlike everybody else in the universe, right? That receives um, light into their eyes. That's why you can see, because light comes into your eyes. Superman had the power to send light out of his eyes, X-ray vision, go through a wall to see what's on the other side of the wall. Okay, and here you see it. Okay, Superman's X-ray vision. Okay, so he could see right through the wall and see things. So it came out of his eyes. It's not like, the image there went through the wall and reached his eye. It was the other way around. So he had this X-ray vision. Very powerful stuff, right? But see, these people are saying something else. They're saying they're more powerful than Superman, more powerful than God. They can, that seeing through walls, that's kid stuff, kindergarten stuff. These people can see nothing, absolutely nothing. They can see nothing. And here's one fellow, he says, hooray, I can see nothing, Sounds like the last words of a blind man, a man who's just gone blind. Yeah, they can see nothing. Not even God can see nothing. Okay, and that's what they're saying when they say they can see space out there. Okay, so we have a problem because we have more superpowers than, these people have more superpowers than God or Superman. They can see nothing. No, space is nothing. You cannot see space. What you're seeing is the objects, and then you see this contrast, and when you say, I can see space. Now you cannot. Hopefully you cannot see nothing. Okay. Okay, so what is space? Well, you saw some definitions. It's a synonym of the vacuum, and also emptiness, nothing. All these words are synonyms, perfect synonyms in physics. And here you have a definition of vacuum. Okay, again from Wikipedia, is defined as a space with little energy. Okay, so vacuum has very little energy. What's energy? A concept. Okay, there's no physical object called energy. Energy is just a number. Okay, what is it? Giga, electron, volts, ergs, or whatever. All these are values of energy. Energy is a number followed by a unit. Okay, so energy is not a thing. Energy is like love. You can't say love does this or love does that. Despite the name, the vacuum still has quantum fields. Again, fields, energy, they have all these concepts. What do you mean it has quantum fields? Does the vacuum have quantum fields like I have a penny in my pocket? Is that how it has quantum fields? A true vacuum is stable because it is at a global minimum of energy and is commonly assumed to coincide with the physical vacuum state we live in. Okay, vacuum state. Great. Love the terms. It's a vacuum state. Here you say a physical vacuum state. What is it? A configuration of quantum fields representing a local minimum but not global minimum of what? Of energy. Again, we have these vague words, never been defined. Nobody knows what it is, and they just put them in there. And people say, oh, okay, I understood now. Vacuum is something that has energy, a little bit of energy or a lot of energy, This type of vacuum state is also called a false vacuum. I think what's false is something else. It's all of quantum. That's what's false. The quantum vacuum state is the quantum state with the lowest possible energy, whatever that is, okay? And what's a quantum state? It's a mathematical entity. That's what it is. Quantum state is a mathematical entity, whatever an entity is to these people. No, it's not an entity at all. It's not a thing. But see, they confuse you with the definitions that they have, and people say, oh, it's a thing, and energy is a thing, and vacuum has a lot of these things in there. And they're talking about concepts, abstract concepts. They never defined them. They don't know what it is. They treat them as physical objects. That's the whole problem. It contains no physical particles. Okay, so what does it contain? The term zero-point field is sometimes used as a synonym for the vacuum state of a quantized field, which is completely individual. According to present-day understanding of what is called a vacuum state or the quantum vacuum, it is by no means a simple empty space. So the vacuum is not empty, okay? The vacuum itself, right? We're not talking about what it contains inside it. The question is the vacuum. Is that the same thing as space? And is space the same thing as vacuum? And if they are they, once we remove all the particles, is there something there? And they say, yeah, there's still fields and energy and who knows, mass. Okay, all these concepts invented by the mathematicians. The vacuum state is not truly empty, but instead contains fleeting electromagnetic waves and particles that pop into and out of the quantum field. What are they talking about? They're talking about virtual particles. Okay, and they have all these. So the question is, where are these particles coming from? Are they being made by God, the angels, the spirits? Who makes these particles? So are they saying that space is made, the vacuum space, right? Whichever of the two, because they're synonyms in physics. In physics, are they made of particles? Is space made of particles? Are we sucking one of the particles of space that formerly made comprised space? Now we're sucking it into the real world, this virtual particle that comes in and goes back out so fast that they can't measure it. So they say, oh, we could measure it. It escaped again, so they can't measure it. But that's not the point. The point is, what's their reasoning? Are they saying that the particle is coming in from the vacuum into the real world and then immediately going back in to fill the hole it left behind in space? A hole in space? I mean, what are these people talking about? It makes no sense whatsoever, their whole interpretation. None of it makes any sense anymore. And just in case you thought that was the end of all the nonsense coming out of quantum mechanics, most of you know, or that are into the subject, that quantum mechanics says there are four forces. I call them the four horses of the apocalypse. The four forces. And now, the other day, they discovered a fifth force. So we have another force. Okay, it says scientists believe they could be nearing the discovery of a new fifth force of nature. I mean, all we have is pull and push, but now they've invented maybe and perhaps, and I thought that was the end of it, but now they're going on to a fifth force, which I have no idea how they're going to call it. Okay, it came after an experiment, he says, and then it continues going, but if you look at the bottom, it says, so-and-so, a senior scientist at Fermilab said, we are looking for an indication that the muon is interacting with something that we do not know about. So mysterious. It could be anything. New particles, new forces, new dimensions, new features of space-time, anything. So what these people are doing, is creating just names for stuff that they don't understand. And they say, okay, we saw a new phenomenon. We observed it in the lab. We cannot explain it. We'll call it Joey. And the other one's called Johnny. And the other one's called field. And the other one's called energy. And the other one's called mass. And the other one time. So they give all these names out there. They have no idea what they're talking about anymore. And they try to give physical interpretations. Because if they stay within the realm of math, and they do equations, and just keep it completely in their loony asylum, no problem. Just keep it in there. But when they come into the real world, say, let me interpret the real world for you. And you say, okay, interpret it. Well, say space-time drags, the Earth drags space-time around itself. And this particle over here affects that one over there instantaneously with no mediator. And you say, well, but that sounds like magic. And they say, no. We've proven it in the lab. So the issue is they're telling you with a physical interpretation. Their physical interpretation is that there's instantaneous connection between this particle and that particle, or that Earth drags space-time around when you can't drag time around. And they try to they give you a physical interpretation. They say they proved it. You say, well, we don't understand it. I mean, what are you trying to say? And they say, well, we don't understand it either, but we proved it. So we have this problem. Now they have the fifth force. Okay. So these are the questions we need to ask regarding space, okay? Questions regarding space. Is space a thing or a concept? Because if it's a concept, we cannot talk about whether it's finite or infinite or what the shape of it is, okay? Because it's a concept. It's like saying, what is the shape of love? Is love infinite? Is love finite? Is intelligence finite? Is it infinite? What are we talking about? So if it's a concept, you can't use the words finite, adjectives such as finite or infinite. Okay, so we're talking about or treating space as a thing when we talk about finite and infinite. Okay, so we're going to rule out concepts at this point. Okay, by the way, things we point to and concepts we define. So since we're going to deal with space as a thing, we're going to forget about definitions. We want to be able to point to space and say that's space. And hopefully it's not like the blind man says, hey, I can see nothing. Okay. Is space finite or infinite? Okay, that's the main question. Okay. Infinite space, we're talking about a structural issue. Okay. If you're talking about infinite time, like expansion of space. Now you're talking about something else. You're not talking about the structure. You're not saying this is the shape of space. Now you're talking about what? Incessant motion. You're saying this thing is infinite. What do you mean by that? Well, it extends forever. It continues rolling on and on and on and on forever. That's not a structural issue. Now you're talking about something expanding. We'll use the word through time or something in motion. Okay? What's outside of space? That's the other big question, because if it's a physical object, we're going to treat it like a physical object. You have to identify what gives it form. What is outside of space? What provides the background to space? I mean, the moon, we have space provide the background, this dark stuff that's out there, which is nothing. Okay, space, vacuum. But what's gives contour to the vacuum? Is it thought? Is it a dimension of some kind, that somehow encapsulates it? That's what we have to get to the bottom of. Okay, and just in case, here we had Hawking the other day. I want to just make sure that we understand that when we're talking about finite, we're talking about the extent of a physical object, like the Earth there, right? We say the Earth is finite. Why? Because it has a surface, all around. And when Hawking says that it's unbounded, he's talking about something else. He's talking about rolling around, walking around space, walking around the universe, walking around the earth, whatever. So he's not talking about structure anymore. He's talking about walking. And we don't use the word unbounded, we use the word incessant. Okay, you're talking about incessant walking, not infinite walking or unbounded walking. And this is where they do word salad. That's what they're doing. They're doing semantics, They're playing around with semantics. Okay, so where do we start with this thing called space? I mean, how did we get into so much trouble? And, we have to do a little bit of history, because it turns out that none of the ideas that you see today originated today. What they've done is they reinvented the wheel like 100 times now. Okay? The issue of the infinity of space, what space is and whether it's infinite or finite, has been around but for thousands of years now. Thousands of years. It's been touched upon by just about everyone throughout history. Everybody asks the same question. And so all these questions, all we have to do is go back in time, and we'll find out the people who created the first questions. I mean, officially, because they put them on the books. Maybe the ideas already preceded them. Maybe the Sumerians and some of those people whom we have very little information about regarding these issues, they already asked the same questions. But it turns out we have to go to the Greeks, because that's what we have. Okay, so here we have one fellow. His name was Giordano Bruno, and he was burned at the stake in 1600. He was burned at the stake, among other reasons. We don't really know why, okay? Because this fellow said many things, and we don't have the court records for what happened to him exactly. We don't have the printouts of what happened in court. But one of the issues was that he was saying that the universe is infinite. He had this idea, this cosmology in his head, that the universe was infinite. He got some of those ideas from, people in those days that were questioning, astronomers that were questioning whether, the universe was finite or infinite. They were asking these questions. The problem is that an infinite universe contradicted the Bible. And the fact that there could be other worlds out there. No, this is the only world. That's the way it was. The Bible tells us so. So he got into trouble, and they burned him at the stake. His trial, by the way, lasted 7 years. He was acquitted the first time, but then the second time they brought him to Rome, good old Rome, and they burned him at the stake. Get rid of him. Okay, but he wasn't the first one by no means. We have people way before him, and here you have the origins, at least from our Western thought, where we trace most of this stuff. You have all these schools of thought in ancient Greece, and by the way, all these are not at the same time. Some, they were staggered, so you can go in there and go 200, 300, 400, 500 years before Christ and find the different schools in there. And so we're going to start with some of these to show, what the thought was, what the Greeks we're thinking and how we inherited some of this stuff today. We're still trying to figure out what space is. Okay, here we are. We have no idea. Nobody can tell you what space is. And one of the first guys who touched upon it was Hesiod. Hesiod was the guy who essentially told us today about the gods of the Olympus. He's the guy who created the first cosmology, how the universe came to be. At least, maybe there were other people before him for sure, but he's the guy who gave us the Greek thought, and that's the one we started working with, throughout the Middle Ages all the way till today. Okay, and so here's good old Hesiod, and he says the following: at first, chaos came to be. Sounds like a politician. Sounds like the state of the world today. Chaos, right? The initial state of the universe is chaos. Okay. A dark, indefinite void. Boy, that sounds familiar. It sounds like, Big Bang. A divine primordial condition from which everything else appeared. Now, doesn't all that sound familiar? He's talking about space-time. He's saying, look, first we had nothing, okay, and we call that chaos. And from chaos, from the singularity, everything else popped into existence. So, all these people today, relativists and so on, they haven't invented anything. They should read a little theogony from good old Hesiod, and they'll learn a lot more probably. And the first guy who talked about, at least in the Western thought again, I'm not going to say these are the first guys, but this is the record that we have today, was Anaximander, and he talked about infinity. He's the first guy who created infinity, so to speak, okay? And you can call it the Apeiron principle, Apeiron meaning no limits, unlimited, okay? The universe is without limits. That's the principle. Peiros was limit, and so Peiros was unlimited, right? Infinite. And he asked himself this question. This is essentially his entire argument included in here, because he loved the infinity. He said, why? Because you ask the question, what is divine? And he says, what has no origin and no end. Okay, so infinity, that's divine. So he loved infinity. He loved it because it gave him a sense of wonder of, the universe. It just stretches forever, And in contrast, you had Pythagoras and later on Plato, and they were against, the infinity. They hated the infinity because they said, we don't understand it. We don't comprehend what infinity is. And so they were, frustrated because they couldn't figure out what this infinity is. So they took a different position with respect to Anaximander. Anyways, a little while later, we had this fellow. His name is Zeno, and some of you know about him. And he said, an arrow should never reach its target, and Achilles never should catch the turtle, the port tortoise or whatever. Why? Because, he has to run half the distance first, and then the turtle moves on a little more, and then he runs that half distance, and it's some mathematical trick where he never reaches the turtle. And the same with the arrow. The arrow first has to go halfway from the shooter to the target, then half of that what's left, and so on down the line. It never reaches the target. So it's a mathematical trick, or like we used to say in engineering, you can prove with statistics, you can prove that an elephant dances on a pin. Math, you can play around anything you want. It's got nothing to do with physics. Okay. And another fellow who came later, and his name was Aristotle, and he came up and he tried to, he not only made a good summary of all the people before him, which is good because then we know what each one said throughout time, what all these schools were saying. But he was trying to, he was against infinity. He did not believe in infinity. He thought the universe, the earth, right, the universe he saw every day, right, he said it's finite. It's not infinite. And this is the picture he had. He had a picture of the universe as the earth in the center. Okay, he had the planets, and the sun and the moon all rolling around the earth. Okay, this was his notion. And then the stars out there, they were so far away, they formed the firmament, some kind of circle, maybe a sphere around the earth. And he said that's where the world stops. That's the finite universe, our universe, right? He could not identify what was on the other side, the black stuff. He could not figure that out. He never even dealt with that. He just said, "Look, the Earth, the universe stops at the firmament." You know, like all these stars stapled on a blackboard or something. Okay, and so he said, "Where did all these people get all the past people who came before him, right? Well, where did I get the idea that the universe is infinite?" And he says, "Belief in the existence of the infinite comes mainly from five considerations." This is in his fourth book of physics, by the way. He wrote extensively, like five sections in that book. He wrote about infinity. He tried to explain what infinity was. So the whole thing, I can't put the whole thing because it's too long, but this is just kind of like a summary, concise a synthesis of what he tried to say. And so he says five considerations. From the nature of time, for it is infinite. So he's saying that time is infinite, meaning in his notion, I guess, time did not start. The gods did not create time, I guess he was saying, or maybe that the gods, for the gods, time was always there because they were eternal. So in that sense, he said time did not start and will never end. So in this sense, time is infinite, right? From the division of magnitudes, you can take from 0 to 1, you can chop it off as many times as you want, and you'll have infinity of numbers, right? From that which things come to be is infinite. In other words, he's saying that everything has something that preceded it. Essentially, that's what he's saying. Maybe talking about motion in a sense or indirectly here. Because the limited always finds its limit in something, so that there must be no limit if everything is always limited by something different from itself. Essentially, he's saying there that, if there's something called the infinite, then you have other objects that are in the way, and the question is if it can chop it off, it can stop it to some degree, then it's not infinite. Okay, so he's saying, but these are the considerations. These are the things you have to keep in mind when you're analyzing the infinite. And then he's saying not only number, but also mathematical magnitudes and what is outside the heaven are supposed to be infinite. Okay, and so he's kind of saying that infinity's out there, and I'm not going to deal with it. But as far as he's concerned, our universe is finite. It ends at the sphere that that forms the where the stars are at. Okay, so the firmament. Okay, so he continued and said something else here. He said, the fact that what is outside is infinite leads people to suppose that body is also infinite and that there is an infinite number of worlds. Okay, so this is what got good old this fellow that that was burned at the stake, because he was talking about infinite worlds. Okay, he said, why should there be body in one part of the void rather than in another? Mass must be everywhere. If void and place are infinite, there must be infinite body too. For in the case of eternal things, what may be must be. If it, infinity, right, exists, we have still to ask how it exists, as a substance or as an essential attribute of some entity, or in neither way. Is there something which is infinite or some things which are infinitely many? So these are the questions, and again, we're confusing here many things versus structure, whether something is infinite. Okay, so these people keep going back and forth because they're confusing uh, um, many trees. Forest, is a forest infinite because it's got many trees? That's one issue. And another issue is whether an object can be infinite. Those are two different things. And then you have the infinity of mathematics, the number line, it extends forever, and time, and all these things. So they keep mixing all these things. They try to use mathematics, they bring it into physics. And so in mathematics, the number line is infinite. In physics, it's space that is infinite. And the question is it infinite? Well, how are we going to prove it? Well, the way you prove it in mathematics is you count until you die. And then someone else continues, and that goes on forever. And there you proved infinity. And in space, you have to travel with your spaceship, all the way to the edge of space, and then keep going and going and going until you find a wall or a fence that you cross into whatever's out there, whatever thing encapsulates space, right? Okay, there were lots of people in between, but we're going to jump directly to Mr. Nicholas of Cusa, and he proved a couple things. He was one of the first to talk about the infinity of the universe, right? Even before people like uh, Galileo, right? So Cusa came before him a little earlier. And it says, it is impossible for the world machine to have this sensible earth, air, fire, or anything else for a fixed and immovable center. Why did he say that? He says, for in motion there is simply no minimum, such as a fixed center. Mr. Kusa here, and Nick, good old Nick, he destroyed Heisenberg's uncertainty principle right there. Because what he's saying, motion, you cannot take it to a point where there is no motion. Because why? When you have no motion, what you have is location. In other words, if you take the limit of motion as x equals 0, at 0 you have location. Because that's what motion is, a bunch of locations. Okay, so he destroyed Heisenberg's uncertainty principle, his indeterminacy principle, which says that when the ball moves, it doesn't stand still, and when it stands still, it doesn't move. Great, he got a Nobel Prize for that. And then Cusa continues, says, and although the world is not infinite, it cannot be conceived of as finite, since it lacks boundaries within which it is enclosed. Okay, so I don't understand what he meant there because he's got a contradiction. But he's saying that it cannot be finite because it's got no boundaries. Okay, that part I understand. The infinite part that went through his head, I have no idea what he tried to say there. And he continues, says, therefore, just as the earth is not the center of the world, so the sphere of fixed stars is not its circumference. In other words, the firmament. Okay, so he was saying the universe is infinite. That's essentially what it's saying, or space, right? Space is infinite. It's got all these stars, and the universe or space extends forever. That's essentially what he was saying. Okay, so how do we do it in science? Okay, well, we try to do it a little different than these people, and we usually, say that we have to put it in the context of the universal movie. And the question is, does space fit one frame of the film, or do we need to have two frames of the film to talk about space? Okay, and for those of you who are new, well, what we're saying that is in a single frame of the universal movie, we have static concepts. That's the yellow part up there, some of the concepts that belong in a single frame. And then at the bottom you have concepts that are dynamic concepts that require at least two frames of the movie, if not more. Okay, so you have static concepts on the top and dynamic ones on the bottom. And the question is, where are we going to put space? Does space require motion to be conceived, to be understood, if it's a concept? Okay, so that's, if it's an object, you should be able to point to it. It should occupy a single frame. But if it's a concept, the question is it a static concept or is it a dynamic concept? Okay, that's the question. Okay, and one of the things Kusa did was something they do today also, and he tried to prove infinity, okay, geometrically. And he did something that a lot of mathematicians do today. Again, they haven't invented anything new. They say you take a circle, right, and you keep making it bigger and bigger and bigger and bigger and bigger. At some point, you're going to get to a point where you have a straight line. And he says the expansion of a circle approaches infinity because a straight line is infinity, and that's what you get when you expand a circle bigger, make it bigger, bigger, and bigger and bigger. And relativists have come up with this idea also that the universe is flat for the same reason, more or less. They have this going through the backs of their minds. They're saying if Big Bang expands. It's a globe. It's an expanding ball, right? A balloon. So it's expanding, expanding, expanding. Well, at some point you get to a part of the universe where it's essentially flat. That's their argument. That's the same argument that good old Nick suggested here. And it's wrong. No matter how you look at it we don't care about math, but in physics, it's absolutely wrong. It's a wrong theory, argument, whatever you want to call it. No matter how big the sphere, it's always going to be curved. Hopefully. It never turns into a straight line anywhere on a sphere. But these people say, well, you make it big enough and then you have a straight line. No, it's always a curve. Even I don't care how small the chunk you take, it's always going to be a curve. Because then you're not talking about a sphere anymore. But this is the notion these people have. And again, Cusick came up with that, not the relativists. Okay. Okay, so what do I do? What is space? Is space infinite? Is it finite? Is it a thing? Is it a concept? Let's try to see if we can get to the bottom of it. And one of the best ways to do it today, fortunately we have all this technology now, is go to ChatGPT and ask the question there. And so we ask the question there and it says, is space infinite? And this is what good old Chat told us, the robot. Space is a vast and mysterious concept. Concept, okay. It's a vast concept. I mean, how vast is it? I mean, is it big, is it cubic, roundish? What is it, What kind of concept is it? That scientists are still trying to fully understand, okay? 2,000 years later, right? The current scientific understanding is that space is not infinite. Well, hopefully not, because if it's a concept, then hopefully I've never seen an infinite concept. Maybe love, intelligence, but even those, I guess, are not infinite. But rather it is expanding. So we have a concept that is expanding, okay? This is the Chat GPT, okay? This is the top of the line, right? Cutting edge here. The exact boundaries of space are still not known, but scientists believe that it may be finite. Okay, so we have a concept that is infinite, but could be finite. Maybe it's infinite, who knows, It's expanding. Concept that's expanding. Okay, so, try to ask the question to good old Chat, and he'll give you this nonsensical answer. Okay, so what they did, university, I think it was in Australia, they asked 5 experts, leading experts, physicists and scientists, etc., to find out, what is space? I mean, is it infinite or is it finite? Please tell us, once and for all, let's get it over with. And so they asked the question, is space infinite? Expert number 1 said, the short answer is, we don't know. Okay, expert number 2, I believe so. Space appears to be expanding in all directions. Okay, another one says, there's a limit to how much of the universe we can see. The observable universe is finite in that it hasn't existed forever. A flat universe could be infinite. So they think it's a question of proof. They think it's a question of sending your spaceship out there and taking pictures or, some probe out there that would tell us, whether the space is infinite or finite. They think it's a question of experiment and observation. Okay. Expert number 4 says space is finite. If space is finite, then it would have an edge. But imagine flying to the far reaches of the universe. It seems inconceivable you would find an edge. If the universe is a donut, rays will gradually curve with the shape of the universe and eventually wrap back in on themselves. In an infinite universe, the rays would continue forever. Scientists have already begun to look for evidence, okay, of not just the size, but also the shape of the cosmos. So they have an infinite time ahead of them to figure that one out, okay? What does expert number 5 say? Space is finite. If finite and I set out in a spaceship, I would never reach a boundary, but I would travel for an infinitely long period to prove it. In other words, he can travel forever, and you would always say, well, travel a little more and find out if it's finite over there, We know that space had a beginning some 13.8 billion years ago. We know from observation that it's expanding. So, okay, we know it's a physical object, it's finite, it's expanding, okay? There will be an ending. The universe will not persist forever. It has a finite existence in time. Therefore, at some stage, my spaceship will reach an end. So this is how they figure out whether space is infinite, finite. These are the experts. Okay? In other words, none of them have any clue what they're talking about. They have no idea. And these are the experts. So we have made no progress since the days of the Greek regarding space, whether it's infinite, finite, what it is there something outside of it? We have no idea. These people have no idea. Here in science, very easy. It's kindergarten stuff. It's baby stuff. You don't have to go to college. You don't have to go to high school. You don't have to go to elementary school. If you went to kindergarten, you've got enough intelligence, enough knowledge to understand what I'm going to say here, okay? What do we do in science? Well, we define words. That's where we begin. We define words. So what is space? Is space a what, or is it a concept? Is it a thing, or is it a concept? And so that's where we start. We say, look, physics requires an object, okay? You can't do physics without an object. And we have something, that which has shape. What is nothing? That which doesn't have shape. See how simple it was? And so we have now a definition for something and for nothing. What is a synonym of nothing? Space, vacuum, void, nothingness. Straightforward? Okay, there you have examples. Something, there's a something. I don't know what it is, but it looks like it has shape. What's nothing? That which doesn't have shape. See how simple it was? All these years, all they had to do was define the term so we know what we're talking about. Then we know what nothing is and what something is. And we know what space is because space is nothing. Okay, very simple. Either it has shape or it doesn't have shape. If it has shape, it's a something. If it doesn't have shape, it's a nothing. We're done. Okay, and we call that nothing space. We also call it vacuum, and here's another version of that. Vacuum is simply another word for nothing. The two terms are synonymous. They're synonyms. The word space is also a synonym of nothing. Nothing, that which doesn't have shape. Something, that which has shape. See how easy it is? Nothing and something are antonyms. These rigorous definitions can be used consistently, rationally, scientifically. Now you can understand me. I'm saying when I say nothing or space or vacuum, I'm referring to that which doesn't have shape. Whereas something is that which has shape. Those who have different definition for these terms are welcome to define and defend their proposals. So if you don't like my definitions, hey, there you have it. Just fill in the blanks right after the colon. Tell me what nothing and something are. Don't tell me I'm wrong. Don't tell me I have no idea. Define. Or like a fellow there at the Rational Science Group says, don't whine. Define. Okay. Okay, so here we have again the universal movie. Okay, and the question is where are we going to put space? We're going to put it at the top or at the bottom because it's a concept, remember? And so it's that which doesn't have shape, and we're saying that's contrast with that which has shape. So we have two objects, or one treated as an object, and that's what a concept is, a relation between two objects. So the question is, it's a concept. Space is a concept. It's the same thing as nothing. Are we going to put it at the top as a static concept? Are we going to put it at the bottom as a dynamic concept? Do we need motion to understand, the word space? And if it doesn't have shape, then it's obviously a concept. That's the first thing. Then the question is, do we need to have motion in order to understand it? And here we have it. Okay, we have, we're going to put space at the top, okay, because we don't need motion to consider space. That black stuff there, we'll call it stuff, for lack of another word. We can say that which has no shape, that meaning any word in the dictionary, right? Or referring to a concept. And the question is, the black stuff there, that's space. We do not need to see two frames in a movie to understand what space is. It's the one that gives contrast to all those little stars there, galaxies, whatever. We don't need two frames in the movie. Space is a static concept, okay? Meaning vacuum, meaning nothingness, emptiness. You can use any word like that, any synonym, they're all valid. Okay, we use space or vacuum typically. Okay, now here, let me show you if you're going to make a trip with your, because we're trying to find out also if it's an object, if it's a thing, space is a thing, what's outside of this thing? That's important too, because if we're going to look at shape, this fellow was saying that there are people out there trying to figure, trying to run experiments or some observation to figure out whether what the shape of space is, right? Because it's finite, so they're trying to find out what the shape is. And the question is, okay, you go with your ship, right, to the edge of space. What do you think you'll find on the other side of space? What can contain space? That's the question, okay? And so here's space, and I'm going to set in motion here. little spaceship. Give me a second here. Set it up. And we're going to go with our spaceship, right? And we're going to try to go to the edge of space, okay? There we go. Okay, we're going to fly to the edge of space with our spaceship. And the question is, what are you going to encounter once you cross that barrier, that limit, that fence? You're in the white region now. Okay, there you go again. Okay, what is the white stuff that gives shape to space if space is a physical object? And again, I'm showing it in 2D. You can imagine this in 3D, right? I don't think you can imagine it in 4D. So the question is, what do you think you'll find, on the other side of space? Can you imagine that? Are you talking about intelligence? Is that what surrounds, or thought? Is that what surrounds space? Is it a dimension, the fourth, fifth, sixth dimension? What are we talking about? What's on the other side of space? What do you think could contain space anyways? So that's the million-dollar question for you to think about for next week. We'll see you then. Bye-bye.